In the previous example, we had variables on both sides of the equation, but they were both underneath radicals. So squaring both sides just got rid of the radical. It didn't add anything extra to our process. Note that in this example, we have an x, a variable on the left side of the equation, which is not under the radical. So when we go to square both sides, which we still want to do in order to get rid of the square root on the right, the square root and the square cancel on the right, but not on the left. That just becomes an x squared. This is where quadratic equations can start coming into play. We've squared both sides, and now we have an x squared that we need to contend with on that left-hand side. On the right, the radical canceled just like the last examples. So far, so good, except it's quadratic. So we need to pick one of our quadratic solving methods. You could factor, you could complete the square, you could even do quadratic formula. I recommend factoring because it's the fastest of the three. So in order to factor, we need to be in standard form. And just as a reminder, standard form is ax squared plus bx plus c equals 0. In other words, everything on one side of the equation and a 0 on the other. Factoring and quadratic formula do not work unless you're in standard form. So we need to go ahead and get this equation into standard form. So let's do it. It's not too bad. The x squared's already on the left, so we can move things to the left. In order to do that, I'm going to subtract an 18x from both sides. And I'm also going to subtract, I'm going to add an 81 to both sides. Essentially what we're doing is just switching all of the signs on everything we want to move. What used to be a positive 18x is now a negative 18x. What used to be a negative 81 is now a positive 81, and it's all equal to 0. So we moved everything to the left-hand side. Again, we have options here for how to solve this, but factoring is going to be quicker. I need two numbers that multiply to 81 and add to negative 18. If you need a primer on factoring, I can upload an additional video for that. Just let me know. As far as this one, two numbers that multiply to 81 and add to negative 18, well, that's going to be negative 9 and negative 9. Notice I got the same factor twice. So I have two possible solutions for this quadratic equation. They just happen to be the same thing. X is either positive 9 or it's positive 9. So this is one of those somewhat boring quadratics. Two solutions, but they're the same number. So in the previous section, we checked our work by hand. It's important to know that you can also do this using the technology. I'm going to pull up a TI-84 because that's what we're all using. So it's worth it to go back and double check. We're expecting that 9 to be a solution of our equation. So let's check. We had an 18x. In this case, x is 9. 18x minus 81 under a radical, and we expected that to equal x. Well, x is 9. So if I hit enter on my calculator, I had better get a 9. I did, so that 9 is a solution. It does work. No, you don't have to do it twice. That second 9 is just redundant. So in this case, everything worked out kind of nice. Let's take a look at an example where things don't work out so nicely. And that's example 2. Note that at first glance, there's not a whole lot that's different here. We're going to square both sides. The square and the square root cancel, and I'm left with a quadratic. Just like last time, in order to deal with this quadratic, I need standard form. In other words, it needs to be equal to 0. So to get that, I'm going to add 10x to both sides. And I'm also going to add 25 to both sides. So far, it's not any different. X squared plus 10x plus 25, whole thing's equal to 0. So, here we go again. Notice this time, it's two numbers that multiply to a positive 25 and add to a positive 10. And again, if you need a quick review video on factoring, just let me know. I can make one of those as well. In this case, our two numbers that multiply to 25 and add to a positive 10 are 5 and 5. So it's very similar to last time. Quick quadratic. We even have the same factor twice. So it's that boring quadratic where the solutions are the same. X is going to be -5 or also -5. That second -5 is redundant. No, you don't need to write it again. Here's what's weird. When I go to substitute that -5 back into the original equation to double check, well, I'm expecting -10 times -5. Let's insert parentheses. Boom. So when I substitute in that -5 and then subtract off the 25, I expect this to be equal to x, and I just said that x is -5. But when I put this in my calculator, the calculator tells me that x is +5. Well, +5 and -5 do not equal one another. So -5 is not a solution to this equation. We have a name for this value -5. We call this extraneous. Extraneous solutions happen when all of your algebra is correct. Nothing that we did here is wrong. Nothing here is broken. It's just that that -5 is not actually a solution to our original equation. If you're interested in a bit more of the theory on where extraneous solutions come from, it really has to do with the fact that we squared both sides of the equation. And I'd be happy to show you additionally either a quick video or a quick graph to really visually get across why squaring can make extraneous solutions happen. For now, what you need to know is double checking your work is important. When you take those two values, sometimes 2, sometimes 1, when you get those values out of your algebra, please plug them back into the original equation, double check that they actually work. As a quick aside, on Math Excel, when you get a solution with no equation, you want option B. The solution is the empty set. This isn't language that we generally use in this course, but what the empty set is it means we have a set of numbers which is empty. So there are no numbers in the set. Hence, no solution, nothing actually works.